One of the greatest challenges is to take something complex and make it seem easy and accessible to the user. There have been many efforts to do this. Often things are broken down into chunks or steps, as each step has reduced complexity in and of itself. Take an IKEA instruction manual, for example. Ideally, these have broken down each step so much that they can be visually represented by simple pictograms. Computers frequently have been the subject of this simplification process, often on the software side, graphical user interfaces simplifying and pushing the technical stuff into the background. There is an interesting side effect to relegating the gears into the background. A computer user now knows less about how computers actually work than they may have had to in the past, out of necessity to use the machine. There is now a barrier. The necessity of understanding computers and their hardware have led to some interesting simplification efforts. One such example is the popular Raspberry Pi series. The whole pewter is here. Just need to add a display, input peripherals, and a microSD, all exposed in its naked glory. A great way to learn, but still a bit complex. Not the case for this little guy. Design of Things 12, BBC Microbit. BBC's efforts to help make computer science accessible go really far back, to December 1981, with the release of the BBC microcomputer, or the Beeb. It's estimated that soon 80% of British schools had BBC microcomputers. This little guy here is the latest in BBC's effort to demystify computing for the masses of children. At first glance, you'll notice how small it is. Is this really a computer? It's half the size of a credit card and not much thicker. The black PCB is quite sexy, with a bold color accent, in this case magenta, repeated for the accent triangles in the top left corner, the Microbit logo, and tiny little triangular button labels. There are two small clicky buttons. In the center is a 5x5 array of red LEDs. On the bottom here are 5 pins for connecting various things like sensors, lights, and motors, 3 volts of power, and a ground. This whole section can also be slotted into accessories like this expansion board. The gold is a great contrast to the black board, but it is a functional choice for conductivity, though aesthetically it looks nice. On the back, we see a nice selection of fine details. There is a micro USB for connecting to a computer. It also has Bluetooth for connecting to mobile devices, a reset button, and a place to input power. Interestingly, this or the bottom pin can be used. So remember the point of this, to introduce kids to computer hardware and programming. It really seeks to demystify the computer. The PCB is printed with a label for each included component, the processor, compass, Bluetooth antenna, etc. So just looking at one is a learning experience. How else does it make it easy to get started? First, think about everything that is included. With only the microbit and power, we can instantly give instructions, input, and see a reaction, output, on the LEDs. The first step isn't to connect to a computer or device. The first step is to simply play with and get to know your device. Check out the first startup sequence. Really accessible, right? and it can scale up to become more difficult and advanced with the learner. The options really are endless, and can be as simple or complex as you like. A solar-powered car moves when light hits the microbit sensors. A Lego robot. Another example of versatile design. Even in the software on a PC, Mac, iOS, or Android device, you can choose more simplified block or Scratch-like programming, or use standard lines of code. The recently released second version adds touch and a microphone, packing the board with even more ways to interact and opening up more possibilities. While I think it's a brilliant design, time will only tell if the microbit has been influential in raising a new generation of computer-literate creators and innovators. Until next time on Design of Things.